everything I'm running is 64-bit except for Adobe is 32-bit. So I'm going to hit more details and I'm going to go to the performance tab. And as you can see, you've got CPU, memory, disk, network. Those are the 4 areas that we can have a bottleneck from a hardware perspective. On a server class machine, you'll just have CPU, memory, and network. Disk won't be there by default. So we talked about CPU already. Let's talk about memory. So here's my memory screen. Let's talk about what's what. So up here, my machine's a little unique. I have 96 gig of memory installed. It's only registering 63.8 gig. So there's 32 gig that it does not register, and that's because the memory is mismatched. It's different. They're different speeds of memory. So there's a 2200 megahertz, and it doesn't like that with the 2400 megahertz, and so the memory's mismatched. But most of the time, the numbers up here will match. All right. So what are these numbers telling me? In use is how much RAM is being used. So I've got 64 gig of RAM. I'm using 19 gig. I have available 44 gig. So this is the number that when this gets low, so we're talking about RAM, when this gets low, we start paging. Remember, Memory Manager can store data in one of 2 places, physical memory or the page file. I prefer to save it in physical memory because it's way faster. But if I start running out of RAM, I will move stuff to the page file. This is the indicator of if you're running low on RAM available. Now, in older versions of the operating system, what client version are you all running? Is it Windows 7, Windows 10, Windows 8?
Windows 10.
Windows 10, okay. So this is what yours looks like. In older versions, it would say like free and available and system cache and total, but so now it just says available. So this is the number. So if on your machine you're down to a couple hundred meg, then there's a good chance you're using your page file. All right, so this tells you how much you're using, but this is the key one here, available. All right, the next thing we look at is this committed right here. So what does that mean? This is how much has been committed. This is how much can be committed. So what is committed memory? It's Memory Manager has committed to allowing the process or the driver to using its memory. It's I hate to use the word reservation, but it's basically Windows is guaranteeing that memory will be available for you. Okay, so this number on the left is how much Microsoft or Windows has committed. This number on the right is how much we can commit to storing your data. I can store 104 gig worth of data on my machine. Where are the 2 places we can store data? RAM and page file. So this number on the right here is called the commit limit, and it is RAM plus page file. This number here equals 63.8. So if I did this, if I go into calc, I know my total is 104. So I have 104 as my commit limit. It's how much I can store. It's your checking and your savings. If RAM is checking and page file savings, I can subtract RAM. I know my RAM is 63.8. And that means I have 40 gig in my page file or my savings account. So if I go and I take a look, you can see here, 4179332 divided by 1024 divided by 1024 equals 40.2. Should be really close. So this number determines if you're about to start paging. If this number gets low, you're going to start slowing down. Your machine's going to slow down. And I'm going to start using more and more of this. If this number on the left gets close to the number on the right, that is when you're going to run out of RAM and page file. You may get a message that says your system is running low on virtual memory. Try increasing main memory or page file. Have you all ever seen that message? It's like a yellow pop-up box.
Yes.
Yeah. That means that this number on the left, Windows has committed every place that it can commit to. You've used your checking and your savings account. So you spent all your checking account, you started dipping into your savings account, which is the page file, and now your page file is full. And so now what's going to happen is when you go to ask for memory, when the application goes and asks for memory, it's not going to get it, and that app is going to hang. And either your applications will stop working or Windows will stop working. It is a catastrophic event. You have no more money. So what do you do? So I typically use this whole checking and savings scenario. But basically, it's the same thing you would do at your house. So if in your bank account, this is your checking account. Let's just say you have $1,000. This is your savings account. So you have $2,000. For a total $3,000. The first thing you're going to lose is your checking. Available. So if your available goes down, that's your checking. Then you're going to have to start dipping into your savings. That's your page file. When you have, so the combination of the two is your commit limit. As soon as you have exhausted your checking and your savings, which means you have spent $3,000 and you only have $3,000, your next charges are going to be declined. And things are going to break. So in real life, if you had this problem where you spent all your checking and all your savings, you have a couple options. You can go get another job, a second or third job, and you can increase your checking and your savings. So I can add more RAM here, or I can add more page file. RAM is the preferred option because it's faster, but it's way more expensive. But I would argue, before you start throwing RAM at this, just like before you go and get another job, maybe you should look at where you're spending your money and see if there's things that you can cut out and stop spending money on. So if you go eat out for lunch every single day, maybe you can start taking your lunch. If you go to the movies, maybe you can start staying at home and watching Netflix. So before you start throwing more RAM at your systems, make sure the money you're spending, the memory you're using, is expected. Hey, you've got Edge open, or you've got Chrome open, or you've got Firefox open. If you close these programs, your machine's going to run faster when you're not using them. So I would go and evaluate if you're running out of all this memory and your page file is increasing and it's taking up the hard drive. Go find out where all the memory's going. Now, 8 gig honestly is not a lot. Depending on the security products and what they're doing in Teams and Office, it's not necessarily a lot of memory. The standard now is close to, most customers are using 16 gig because of all the security products and different things that they run. So 8 gig's not a lot, but on your servers you may have more. So before you throw more memory on your servers, see where it's going. So how do I tell who's spending all my money? I can go to the Details tab and I look at this memory, active private working set. Working set is RAM. Anytime you see the term working set, that means you're actively working with it. That means it's in RAM. So right now I have a program called WPA open. So if my machine was having a problem with available memory, I know by closing WPA, I'm going to get almost 2 gig back. So I'm going to come and I'm going to close the program on my other screen. And you can see it just jumped from 44 to 46. And I just reclaimed 2 gig. I can also close Edge down and get 684 meg. So the first thing you want to do is you want to identify, do you have a memory problem? If your available is low, your machine's going to be slow. Let me write this down. All right. If you're low available, it's going to slow your machine down because you're going to page. High committed bytes is going to slow your machine down and possibly failing hung applications in OS. This is where you look. Details, private working set. So I'm going to come here and I'm going to close programs I don't need. Or instruct your users. Hey, when you're not using this, you may want to close it.
Right.
All right. Any questions on that? All right. This right here, page pool and non-page pool, is not as important anymore in 64-bit. It used to be very important with 32-bit, but in 64-bit, the numbers are so large we don't care. This over here is pretty self-explanatory. The speed of the memory, how many slots your machine has, and how many are used, the type, and then hardware reserved. My hardware is reserving 32 gig because my memory doesn't match the speed. All right, so let's look at CPU. There's one other thing I want to show you that I did not show you that is really important that I've been running into mostly on clients, but it sounds like maybe you all do some escalation support for clients as well as server stuff. What's supposed to happen is, so we already know the CPUs, we know the kernel time, we know how to change the graph, but one other thing I did not mention is this speed and this base speed. So the base speed is what the processor is advertised to run at. It's how fast, 2.9 gigahertz, it's how fast it executes instructions. Your speed is how fast it's currently going. So you may have a car that does 100 miles an hour, but that doesn't mean you're driving it at 100 miles an hour all the time, because that may cost you gas, and it's not very efficient with your gas. So if you're just cruising around the neighborhood, you may be doing, I don't know what this is, yeah, I'm assuming you all are in kilometers, but maybe you're doing like 25 kilometers an hour, 30 kilometers an hour. Yeah, you're conserving gas, you're going slower, everything's fine. But if you've got somewhere you need to be, or there's a bunch of people behind you that are waiting for you to go through the neighborhood, you may want to speed up, and that's what this number does. So as the utilization, as your CPU starts to get busy, your speed should increase to keep up with how busy it is. It's like if you're a cashier and you're checking out people at the register. If there's only 1 or 2 people in line, you can probably go at a decent average speed, nothing too fast. But if you start to notice, wow, now there's like 10 people in line waiting to check out, you may want to speed up and go faster. So what I've noticed though in the last couple of years is sometimes, so what should happen is as the utilization goes up, so should your speed. Occasionally what's happening is machines are being throttled and the utilization goes up to like 25, 35%, and the speed stays down to like 800 megahertz, like 0.8, 0.9, 1 gigahertz, and it does not go up to this base speed. If that happens, you need to make sure that you all have the latest BIOS and firmware updates for your computers. There's been a lot of bugs in tuning that has been developed. I've worked a lot with Intel and Lenovo on developing and tuning the BIOS and some of the thermals. If the laptop gets too hot, it can also throttle the speed so it doesn't overheat. So just make sure that on a machine, if someone's complaining that the machine is slow, or even on your servers, just make sure that as the utilization increases up to 40, 50%, you should be getting almost your max speed. And if you're not, and the speed is very slow, just make sure it's completely updated and start with that. All right, so we cover CPU, we cover memory. Let's take a look at Ethernet real quick. It's pretty straightforward. Not a lot going on here, and then disk doesn't show up, as I mentioned, in Task Manager on a server. So what do I use for disk and network? So CPU and memory, I use Task Manager every time. But if I want to look at network and disk, you all saw earlier when we were troubleshooting WinDBG, I go into Resource Monitor, and Resource Monitor allows me to look at CPU, memory, disk, and network. Now CPU and memory I don't really use very often because I can just use Task Manager. But disk and network I use Resource Monitor all the time. So the overview tab shows me all 4. But what I like to do is I like to go into disk and I like to sort by total bytes and see what process is doing what on my disk. So if I think that my machine is slow, I check my 4 areas: CPU, memory, disk, and network. So if I verify that CPU looks fine, memory looks fine, maybe it's the disk. So I go in and I take a look at the disk utilization, and the first thing I'm going to look at is active time. How busy is it? If this is completely light blue, it's shaded kind of like this, then I know my drive is really busy. Then I'm going to sort by total bytes a second, and I'm going to see what process is doing what to what file. This works on servers and clients. So I can go in and verify, oh, what is Teams doing, or what is System doing, or SVC host doing? And is it expected behavior, or is it there's some type of scan going on that I do not expect? So if there is, then maybe I'll go and investigate. Maybe I'll kill the process. Maybe I'll stop the service and see, does the performance improve? But this allows me to see what process is doing what to different files. So I know the process, and I know what files, and I know how much. It also shows me the response time. I can add that column by right-clicking and select columns, and you can add response time, and it will show you how fast the responses are coming. I have a solid-state drive, so it's pretty fast. But on your SATA drives or your spindle drives, these times would probably be a higher 20, 30 milliseconds. All right, the other thing I like to look at is network. And this lets me see which process is doing what to what. So I can see Teams is sending some data to this IP address 52.113.73.19. Now this is in the Overview tab. If you click on the Networking tab, it gives you a little more information. So if I click on the actual network and I click on TCP connections, this will actually tell me any type of packet loss and latency that that application is experiencing. This can be extremely helpful if you have an app and they're complaining that the app is slow to respond. Maybe it's because of a bad network connection. So you can go in and take a look and see, is there any packet loss and what's the response time? You can also, this is for the entire machine, you can also filter, as we were doing earlier, just on specific processes. So if I just want Teams, I can come up here and select my Teams processes, and it will filter the results just on Teams. And I can see what process is talking to what port. So this is SSL, secure, and then is there any packet loss, and how long is it taking, and how much data is being is being moved through. So here's my response times, about 103 milliseconds, 63, 94, 76, pretty good. But this allows me to go and kind of gauge, am I having problems with disk, CPU? If so, what files, what process, what disk? As well as networking, I can see what process, and is there any packet loss, or how slow is the connection? And that can be extremely helpful. If you see a graph or something that you want to pause, you can hit monitor and stop monitoring, and that will freeze the screen with the current data points. So you can go in and take a screenshot, or show your colleague, hey, this is the issue, I've got it here on the screen. Just to start back up, you can hit monitor, start monitoring, and it will bring it back up. These graphs on the right hand side just graph what it's showing you on the left. So you can see network, typically that's send and receive, or I think it's saying it's filtered. You can see how many connections, and then your different Ethernet adapters and the utilization for those. So I use primarily Task Manager for CPU and memory, and I use Resource Monitor for disk and network if I'm trying to troubleshoot the two. So those are my primary tools that I use from when I'm looking at stuff real time. If I want to collect data, let's just say on my server, over a period of a week, and I want to do a baseline on how well my server is doing, that is where Task Manager and Resource Monitor are not good tools. That's where I would use a tool like Performance Monitor. So this is probably a good pausing point for today. I know we've gone over a lot of information, but tomorrow we will pick up with Performance Monitor, and I'll show you how to record performance data over a period of time, a couple hours or a couple of days. so you can go back and review that data over a longer period of time. Or if users complain, hey, the problem happens randomly throughout the day, you can record all day, and as soon as the user reports a problem, you can go back and review that. And I'll show you how to use that tool tomorrow, Performance Monitor, if you haven't used it. So we're doing pretty good on time. As I mentioned, there's also going to be another workshop, so I'm trying to spread the content out between the two workshops so we don't, there's a lot in this workshop, so I'm trying to kind of pace us and do a pretty good job pacing, and knowing that the second workshop I can cover anything that we don't cover in this one, and give us a little more time to spend on this one. So today we talked about threads a little bit more. We talked about CPU. We talked about Process Explorer and how we use Process Explorer. We did some debugging with WinDBG, and we analyzed crash dumps. And we also talked about CPU, memory, disk, and network, and what to look for and how to look for it. So I've got more notes here that I took. You all saw me take. So I'm going to paste those into the chat right now. At the end of this, I'll paste this whole text file. But any questions on anything that we've covered today around those specific areas, or anything that you thought about in the last 2 days?
Debug. WinDBG.
I just have a question regarding SQL servers.
Yeah.
I believe that I'm not an expert in SQL, but I believe that we allocate the RAM for the SQL.
Yeah. Yeah.
So like it locks up the utilization. Like for example, we can set it we can set it to at least 80% utilization of the RAMs.
Yeah.
So how are we going to know if it's really fully utilized by the system?
So you don't. So you're saying, like, if we go in and you set proactively, you go into SQL and you say, hey, I want to use 80% of memory, so it blocks that 80% for SQL. Your question is, how do you know, is SQL really using the full 80% or not?
Yes.
Is that what you're asking?
Yes.
So there are specific SQL performance counters that you would have to investigate to do that. But you're right. From an OS perspective, it's going to look like SQL is using, let's just say you have 100 gig of RAM. It's going to look like SQL is using 80 gig of RAM. So you have to go into perfmon, and there are specific performance counters for Performance Monitor that you have to look at for SQL memory. And this, I don't know what website this is, but you have to look at the SQL specific ones. And from an OS perspective, you're right. It's very difficult to troubleshoot because they go in and they grab that memory out of the box as soon as they start up. They grab it, and to us, it looks like they're using it. But how do we know if they're really using it? I don't know enough because I don't typically troubleshoot SQL performance issues. But there are counters that you can use to do this. Now, this right here may be a good article for it as well. So it looks like so SQL Server Memory Manager total server memory, yeah. So this may be an article here. It's not Microsoft, so I'm not going to recommend it necessarily, but it does talk about how to go and baseline it. So I will paste this in the chat of what you can search on, and you could potentially use one of these articles. Or here we go. This is a Microsoft article here. But great question. I don't do a lot of SQL either. I kind of let my SQL folks do it. But here is an article. Here you go. This is counter right here. So let me paste this in here. So that looks like that'll answer. I just don't have a lot of experience. I can determine if SQL is causing the box to have issues, but as far as is SQL using all the memory that it's asked for, that's where that article comes into play. So, good question, but it looks like this article covers the steps to go in and figure that out.
Thank you.
Uh-huh.
Thanks.
Good questions, though. Any other questions on anything we covered today? All right. So for tomorrow, what we're going to do is we are going to come in. We're going to cover performance monitor in the morning, and then we'll transition into some of the more built-in tools like Event Viewer, a Reliability Monitor, which is a client-side tool, Problem Steps Recorder, and then we'll transition probably into network, a little bit of network analysis. Do you all ever do network traces, or is that something that you're interested in, or is that something you don't think you would use very much?
We need that also.
Okay, yeah, no, perfect. So we'll cover that, and then we'll cover the Process Explorer stuff, and we'll see how the time goes. We're doing pretty good on time. Normally, when I teach this over the phone remotely, we can save some time because people come back from breaks on time, and lunches are a little bit shorter, and a little bit less questions as well versus when I'm in a classroom. So we're right on schedule. So I appreciate it. Yet again, we've made it through day 2. We've got one more day to go. But thank you all very much. I appreciate it. As I mentioned, I know it's challenging to sit here and look at someone's screen and hear them talking to a headset, but I do appreciate you all being engaged. Hopefully you're getting something out of it. Rab did ask me today how it was going. Told him I thought it was going pretty well. So he's definitely interested in getting you all the training that you all you all need to help with your jobs. So hopefully we can take some benefits out of this, and you all can make your jobs a little bit easier. So I appreciate it. We've got one more day. I will see you all tomorrow at 9 a.m. Enjoy the rest of your afternoon, and I will catch you all tomorrow morning. Have a good night.
All right.
Okay.
Hello. Thank you.